Welcome to Niranjan's Physics Made Simple. Today we are going to solve a problem on friction. A block of certain mass is placed on the rough inclined plane. It is a rough inclined plane. The angle between the plane and the horizontal is 30 degree. So the mass is not given over here. So let us take it to be m. And the angle is given, that is 30 degree. The coefficient of static and kinetic frictions of the blocks are on the inclined plane are 0.6 and 0.5 respectively. Then the magnitude of the acceleration of the block is, so we should find out the acceleration. So to find out the acceleration, we need to know the force. If we know the force, then only we can calculate the acceleration. So calculate the force that is acting on the block here. So to do that, first we should calculate, right, the forces acting on the block. That is, mg is the only force that is acting on the block. Now this mg provides, because it is an inclined plane, provides a normal reaction force as well, that is mg cos theta. Why this mg cos theta? Because here if you see, the mg is making an angle over here which is 60 degree, and if I see here, and this will become angle 30 degree, which is equal to theta. So I can write mg cos theta over here, and a downward direction force which will be dragging it along the inclined plane will become obviously mg sin theta. So let us calculate the mg sin theta as the force which is acting downwards. First we will calculate that. F is equal to mg sin theta is equal to m into g into sine of 30 degree, u is equal to mg by 2. So because sine 30 is 1 by 2. So that's our force acting on the block to move it in the downward direction. So let us calculate the frictional force acting. Frictional force, as you know, already given by, we are first calculating the static friction. We will check out whether the body is moving. So mu s, that is a static friction coefficient, which will be multiplied by normal reaction to get the static friction force. Normal reaction is given by here mg cos theta. So mu s is given, that is 0.6. It is given over here. Then mu mg, you keep it as it is, and cos of theta is 30 degree. So we are going to obviously get 0.6 mg cos 30 is root 3 by 2, 2 ones are 2, 0.3, yes, that get cancelled, and we're going to get 0.3, and root 3 is 1.73, 1.7 approximately, and if you multiply 1.73 and 0.3, we are obviously going to get 0.17, means 5 to approximately 5 to mg. Clearly you can see that this mg, if you continue to calculate it, it will become 0.5 mg, which is smaller than the frictional force, that is Fs is greater than F, which is the downward acting force. That means frictional force is greater. That means the object will be at object is, sorry, let me do this. Object is at rest. It's at rest. Rest means acceleration is equal to 0.